Cheers for the introduction to HTML, Jason. Hey guys, I'm Alex, currently studying computer science and statistics in the University of Auckland. I went through MSA last year, and I was fortunate enough to land a placement in Southern Cross at the end. I'm excited to be back and hope you guys enjoyed the video. First off, people always say learning by doing is the best way. Although it is partially true, I argue there is a prerequisite before you start the doing, which is to understand what and why that you are doing. I would not trust someone who don't know what they are doing to build my house. Thus, currently the slides help you to get an idea of the essential concept before we dive into the code. Without CSS, the web page will look unorganized, dull, or even boring. So, the overview of this presentation is as follows. We will run through the box model, the size of the elements, how we lay things out, and how we can position them. There are still so much more to cover, such as animation, media query, pseudo selectors, just to name a few. So, every element is a box. The model helps us to understand how the width and the height of an element is set out. It goes a long way when you truly understand the box model, because you will be in full control of the spacing of the elements. So we have two types of boxes. Inline box stays on the same line, whereas a block box breaks into a new line. There are also a few more differences, such as you can't apply a fixed width or height to an inline box. Okay, let me show you an example of the differences that I mean. So, as you can see, we have three items here, 1, 2, and 3. They are all distributed along the same line. So, they are actually list items inside an order list. So, they have a default display style of inline applied to them. Whereas if you see the words element here, it's broken into a new line because it's got a block style applied to it. What if we take away this class attribute? Then you can see it's in the same line as all the other words or text surrounding it. It's because the span element itself has a default style of inline, a default display style of inline applied to it. So going back to our box model, as the picture illustrates, so I'm going from inside to the outside. We have the content, then the padding, then the border, then the margin. The padding is the spacing between the border and the content, and the margin is the spacing between the border and the imaginary space surrounding the box. And there are two different types of box models, sorry. There is the standard box model and the border box standard model. They differ in the way such that how you calculate the width of the content. So here is our standard box model. As you can see, you have these sizes applied to them. So pixel is the basic unit of CSS, the basic size unit, which we will talk about in the next few slides. So here, just bear with me. So this content has a width of 350 pixels and a height of 150 pixels as shown in the picture. Well, it's actual, if you are going to calculate the size of the whole content, the whole box itself, you actually have to take into account of the padding and the border width. So here you can see they've already done it for us. The space taken up by the box, or the width here, is 410 pixels. How it's done is because your inner content has a width of 300 pixels, and you've applied padding to all four sides of it. Therefore, you have to take in account of the right padding and the left padding when calculating the width. So you add 225 pixels to it, which is now 400 in total. Then you add the border width of this box, which is 5 pixels. So at the end, you end up with 410 pixels wide. Similarly, you do the same sort of calculation for the height of this box. Well, you may think it's inconvenient to take into account of the padding when calculating the space taken by the box. Well, that's why they come up with this alternative CSS box model, which is called the border box. So the width that you set out will be exactly, the width here is 350 pixels. No matter the padding that you've set to this box, the box will always take up the 350 pixels wide and 150 pixels tall. But the content will be affected by the padding, of course. Well, let me illustrate you with another example here. So as you can see, we have a standard box on the top and the border box model in the bottom. The goal of this exercise is to adjust it so that these two elements have the same width. Well, in order to do that, we have to understand how the standard box model and the border box model works. Well, let's first calculate the width of the standard box. So we have the content itself has the width of 300 pixels. The padding has been applied to it, so it has this element has a padding of 40 pixels on all four of its sides. Well, margin here we don't really care about when we consider the space taken up by the box itself, because margin just means the spacing between the imaginary space surrounding the box and the border itself. So if we take away this margin, the two boxes will just be right next to each other. So it's just for aesthetic purposes to keep the margin there. Well, if we have the content has a width of, so I'm just doing some simple calculation here. The width has 300 pixels and padding of 40 applied to both sides. That means it has padding of 40 pixels on the left and padding of 40 pixels on the right. And since it's got the border width applied to it as well, so we taking into account of the border on the left and the border width on the right. So this gives us 390 pixels. And if we applied that attribute 390 pixels into this element, so clearly you can see now they have the same width. So I hope this illustration helps you to understand border box a bit better. Now let's jump into the size. So often we would love to control the size of our element using the style attributes width and height. Well, the slides gives an overview of the unit for the size that we can use. Generally, we use pixels for margin and padding as they are generally small concise values and often don't change much. For the size of text, however, we prefer to use EM or REM because we would like the text to scale with the width of the string. Let me give you an example of what each of them really means. So here I'll just do some simple calculation. So pixel is just our base unit, and EM is the size proportional to your parent element. So suppose your parent has a width of 20 pixels. To calculate your EM, if your desired size is, say, let's change this to, well, 15 pixels, then your EM will equal to the size of your desired size, which is 15, divided by your parent width, which is 20. That gives you 0.75. Now, this is powerful because in responsive design, you want your elements to scale proportionally. So if you are going to change the size of your parent, then the width of your children will also change as well. And REM just means the root size of your browser. That varies from browser to browser, but in general, the REM will be set to 16 pixels. And we also have wheel width and wheel height, and we can use a percentage to calculate the width and the height. So let me give you an example. Suppose we have a 20 wheel width, and oh, by the way, the view is just your browser. So if you imagine the text editor that I'm using right now is the browser, then whatever I have right now, let's say my current wheel width is 200 pixels, just an arbitrary number. If we shrink this, now it will become 150 pixels. So yeah, so view width is just the width of your current of your browser, and view height on the other hand is just simply the height of your browser. So if an element has a view width of 20, that means it will take up 20% of the browser width. And if this is for 20 view width, and similarly for view height on the other hand, if you have 35 view height, that will take up 35% of the browser height. Right. And using percentage on the other hand, it's depends on, so generally you want the size of your children to have a size proportional to its parent. So if your children has, so I'm just writing pseudocode at the moment. If your children has a width of 30%, 35%, and imagine you have HTML here, you have div, and this is your div, okay? You have this structure, so this class is, so this is your parent, whatever class you have. This is your children. Now that means this children element will have a width of 35% relative to its parent. So that's the basis that we will cover here for the sizes. So bear in mind, we can, sorry, the examples that we've used are using numeric values strictly to specify the size. But you can also use keywords like small and large to specify the size. Now, next up, we have layout and positioning. So Flexbox and Grid are the centerpiece that controls the layout of the web page. Flex and Grid are the inner display style that we can set on our element on the box. With Flexbox, you can lay elements out horizontally or vertically, which depends on the direction of our primary axis. Let me give you an example on Paint. So here our primary axis, as you can see, is on the vertical axis, and our cross axis is just vertical. It's in the vertical position to our primary axis. So this is when this is the situation if we've set our flex direction to column. If we set our flex direction to row, on the other hand, which is by default, which is what it is by default, our primary axis will be on the horizontal direction, and our cross axis will be vertical to that, which is now the vertical direction. You may ask, why would that be important? Because that is how we determine how we position the elements of the flex items in the Flexbox. So let me give you an example here. So as you can see, we have justified content. So this is the style that you will want to use if you want to position your element on your primary axis. So you can have these sort of position layout here. And if you want to if you want to position your elements across the cross axis, you will want to use align items. So here's an example. So this is when your flex direction is set to row. That means your primary axis will now be on the horizontal direction, and your cross axis will now be on the vertical direction. Because align items adjust the position of the flex items on the vertical direction. If you set it to stretch, each of the flex items will stretch across the whole of the cross axis. And here are some other examples that you can use. So, and with grid, it's very much like a table where you divide the box up into cells. You might ask, should I use grid or flexbox? I'm sorry, there isn't a clear-cut answer, because what can be done by grid can also be achieved through a flexbox. A distinction should be made though. Flexbox focuses on the control flow. That is, you are controlling how the flex item stretches or shrinks, which is why it's called flex in the first place. And grid focuses on the content placement. For example, a grid is broken into several cells horizontally and vertically. What Mozilla has pointed out is that a flexbox controls the space distribution on either row or column, whereas grid can control space distribution of row and column both at the same time. So a rule of thumb is, if you want to control the space distribution on row only, then use flexbox. But if you want to do that on both of your row and column, use grid. So this marks the end of our presentation slides. Without further ado, let's jump into the code.